Welcome. So today we will be discussing the topic of accumulation, consumption, and rate in and rate out. So this topic refers to the part of calculus where definite integrals, Riemann sum approximations, or the area under a curve are used to solve real-life scenario problems. In order to solve these types of problems, one must know how integrals and Riemann sums work to then apply them to find the solution. Thus, this topic is an application of the integral, where integrals can be used to find the net change and accumulation or consumption of many different quantities of growth and decay scenarios. In this topic, integration allows one to determine the effect of a constantly changing rate of change. Lastly, the problems in this topic often ask to determine how much something has been consumed or accumulated in a given time period, so the limits of integration must be set. As we look into our first example, it states the population of a city grows at a rate of R of t equals 200 e to the 0.2 t power people per year, where t is the time in years. At time t, the city has a population of 1,400 people. What is the city's population at t equals 10? And approximately by how many people does the population grow between t equals 3 and t equals 10? So for part A, where it asks what is the city's population at t equals 10, we first want to write out all the given information that the problem already gives us. We know that the function of the population is equal to r of t equals 200 e to the 0.2 t power. Next, we want to set the limits of integration, where our lower limit is going to be equal to t equals 3, because it states that at t equals 3, the city has a population of 1,400 people, so that is going to be our initial value. And our upper limit, we're going to set it at t is equal to 10, because it is asking for the city's population at t equals 10. Next, the last thing we know is the initial population, which is 1,400 people at t equals 3. So after we have written out all our initial values, what we want to do is start setting up the integral, where the population, we want to find the population at t equals 10. So first thing we must do is write out 1,400, which is our initial value, and then our integral, and our lower limit we said was 3 and the upper limit is 10, of the function r of t dt. Next, we could plug in the function for r of t dt, which is 1,400 plus the integral of 3 to 10. So the function that was given to us is 200 e to the 0.2 t dt. Next, we can take the antiderivative of the function, and we get 1,400 is equal to, we would divide 200 by 0.2, and we would get 1,000 e to the 0.2 t after we take the antiderivative evaluated from 3 to 10. Our next step would be plugging in 10 and 3, where we have 1,400 plus 1,000 e to the 0.2 times 10 minus 1,000 e to the 0.2 times 3. After we simplify this, we find that this simplifies to 1,400 plus 5,566.937, which then simplifies to 6,966.937, which we would then round to 6,967 people. So after we set up the integral and we solved, we can determine that the city's population at t equals 10 is 6,967 people. And that is going to be our final answer for part A. Moving on to part B, we read that approximately by how many people does the population grow between t equals 3 and t equals 10. So in order to solve this problem, we must know what the population is at t equals 3, At t equals 3, the population is equal to 1,400, as that is our initial value. So 1,400 people. Next, for the second part, where population at t equals 10, we found that in part A, which is equivalent to 6,967 people. So this is going to be our initial value setups. Now, this is all the information we need to solve this problem. Next, we would simply subtract 6,967 minus 1,400, and after we simplify, we get 5,567 people. So, after calculating, we find that the city's population has grown by 5,567 people between time t equals 3 and t equals 8. Okay, so moving on to, and this first example problem was inspired by a video from Khan Academy. The second example problem, it reads, the rate at which people are entering Prem's premium clothing store is defined by C of t equals 6t squared plus 10, while the rate at which people are leaving the store is expressed by L of t equals 4t plus 10, where t is the time in hours. If Prem's premium clothing store opens for business at 10 a.m., where t equals 0, find A, the amount of customers that have entered the store from 10 a.m. to 3 p.m. So, in order to solve this problem, first we need to focus on the function that's given where the people are entering the store, which is C of t is equal to 6t squared plus 10. Next, we must set up our integral where our lower limit would be 0, since 10 a.m. is the opening time, and where t equals 0, and 3 p.m. is 5 hours after the opening time, so our upper limit would be 5. So the integral from 0 to 5 of c of t dt, we're going to use that to solve this problem, which then if we plug in the function for c of t, we get integral from 0 to 5 of 6t squared plus 10 dt. Next, if we take differentiate the function, we get that 2t cubed plus 10t evaluated from 0 to 5. Next, if we plug in the 0 and 5, we receive 2 times 5 cubed plus 10 times 5 minus 0, since 0 plugging into the function would just give us 0. This simplifies to 300 minus 0, which is 300 people. So, the amount of people that have entered the store is 300 people from t equals 0 to t equals 5. Next, for part B, it asks the amount of customers that have left the store from 12 p.m. to 5 p.m. For part B, we are also going to use the same process we used in part A, except we will be using the second function, which gives us the rate at which people are leaving the store. So L of t is equal to 4t plus 10. Next, we would go on to set up the integral. So our lower limit in this case is going to be 2, because it asks us how many people have left the store from 12 p.m., which is 2 hours after opening time, to 5 p.m., which is 7 hours after opening time. So integral from 2 to 7 of the function L of t dt, which after we can plug in, and we get integral from 2 to 7 of 4t plus 10 dt. If we anti-differentiate this, we get 2t squared plus 10t, evaluated from 2 to 7. The final step would be to plug in 7 and 2. So we would get 2 times 7 squared plus 10 times 7 minus 2 times 2 squared plus 10 times 2. After we simplify this, we get 168 minus 28, which gives us 140. So our solution for part B would be 140 customers have left the store between 12 p.m. and 5 p.m. Finally, to solve part C, it asks the amount of customers that remain in the store at 4 p.m. since opening. To solve part C, we need to look at both functions and we need to figure out what the time t is equal to at 4 p.m. So t would be 6 since 4 p.m. is 6 hours after the opening of 10 a.m. So if we want to find the people remaining at 4 p.m., you must do the integral from 0 to 6 because the store opens at 10 a.m. where t equals 0, and we are solving the solution to the store at how many people are left in the store at 4 p.m., which is 6 hours after the store opens, of C of t, which represents the people of the store that have come inside the store, minus L of t, which represents the number of people that have left the store, dt. Next, we can plug in each of the functions, and we get the integral from 0 to 6 of 6t squared plus 10 dt minus the integral from 0 to 6 of 4 of t plus 10 dt. Next, we can anti-differentiate, where we get 2t cubed plus 10t evaluated from 0 to 6 minus 2t squared plus 10t evaluated from 0 to 6. After we plug in 0 and 6 into the first function, we get 2 times 6 cubed plus 10 times 6 minus 0. Since if we plug in 0 into the function, it would just cancel out. Minus, into the second function, if we plug in 0 and 6, we get 2 times 6 squared plus 10 times 6 minus 0, since again 0 would just cancel out the function. After simplifying, we get 492 minus 132, which is equal to 360 people. So our solution for part C would be the amount of would be 360 people remain in the store at 4 p.m. And this second example was inspired from a video by the organic chemistry tutor on YouTube and number 1 on the 8.1 quiz calculator section. And that is all for our topic of accumulation, consumption, and rate in or rate out. The important things to remember while solving these types of problems is to write out the initial information that the problem gives us, and to also make sure we are setting the limits of integration correctly, and making sure that we are adding the initial value if that is given.